Alright, in this video we're going to talk about Unit 6, Objective 1, Continuity. So, recall from previous math classes that continuity just meant we can draw a graph of a function and not pick up our pencil. So that's the basic idea, the basic understanding of continuity. Except now we're going to make the definition a little bit more precise, although we're still really just saying the same thing. We're still saying we can draw a graph and not pick up our pencil. But what we're going to have to do for the definition of continuous is show three things. So the following three things must be true if the function is going to be continuous. So the first thing, if you're going to be continuous at a point C, f of C has to be defined, right? F of C has to have a point on your graph. It has to be there if we're going to be continuous. The limit as x approaches C of f of x has to exist. So if your limit doesn't exist, then your function is not going to be continuous. Now, if we're given a piecewise function, we might have to verify this with left and right hand limits, and we'll see an example of that in a minute. And then the third thing that has to happen is not only does the limit as x approaches C have to exist, but it has to equal what f of C equals. So to kind of illustrate everything, we can look at example 1. It says draw a function that meets condition 1 but not condition 2. Then another function that meets condition 2 but not 1. And then another one that meets 1 and 2 but not 3. So if we look at just a random function, so at some point C, f of C is defined, so it meets condition 1 but not 2. So the limit doesn't exist at C. So we can have something that looks like this, where we have a point at f of C, but our limit doesn't exist, right? So the limit from the left, the limit from the right, they don't match. So the limit doesn't exist, and you can clearly see that this is not going to be a continuous function if you think about it in the ways we did before. We have to pick up our pencil to draw the entire graph. So condition 2, but not condition 1. So now we're going to say the limit is going to exist, but the function doesn't have a value there. So we can have something that looks like this. So the limit of that function exists, but f of C is not defined, right? We have an open circle. There's no closed circle there, so we're not going to be continuous. I have to pick up my pencil to finish drawing the graph. 1 and 2, but not 3. So the function's defined. The limit's defined, but the function does not equal the limit. So if we draw what we just had a second ago, so we know the limit exists, the function exists, so we can put a closed circle there, but the limit value does not equal the function value. So this isn't going to be continuous, right? We'd have to pick up our pencil, put our dot there, and then go from there. Now, if all three are met, we can think about this one again. So the limit exists. If the limit is what the function is, we close that circle in, and really we can just go straight across and make that a continuous function. So if all three are met, then we're going to be continuous. So as far as AP justification goes, we can really get by with stating just condition 3, because condition 3 is kind of a combination of the first two. Condition 3 can't be true if f of C doesn't exist. So condition 3 can't be true if condition 1's not true. Condition 3 can't be true if the limit doesn't exist. So condition 3 can't be true if condition 2 isn't true. So really, we just need to think about condition 3 for our AP justification. Now, please note, if you don't state exactly what the condition 3 is on your AP exam, you are not going to receive any credit. So how we're going to look at this is from a piece of a free response question on an AP exam. It says, let the function f be defined by f of x equals the piecewise function 1 minus 2 sine of x if x is less than or equal to 0, and e to the negative 4x if x is greater than 0. Show that the function f is continuous at x equals 0. So we need to show that at that point x equals 0, we're going to be continuous. So this is one of those ones where you have to show the right and left hand limit. So what we're trying to show, what we need to show, is that the limit as x approaches 0 of f of x is equal to f of 0. That's what we need to show. So what we should start with first is think about the limit as x approaches 0 of f of x. Well, since I have a piecewise function and we have different functions from the right and the left, we really need to think about a left-hand limit and a right-hand limit. So the limit as x approaches 0 from the left of f of x is going to be equal to, we plug in 0 into the left-hand side of this graph. So if we're thinking about a number line, here's 0, less than 0 is over here. So this is going to be the 1 minus 2 sine of x part, and this is going to be e to the negative 4x part. So we're going to be thinking about from the left being 1 minus 2 sine of 0. Sine of 0 is 0, 2 times 0 is 0, 1 minus 0 is 1. So now we've got to check the limit as x approaches 0 from the right of f of x. Well, that's going to be e to the negative 4 times 0. Negative 4 times 0 is 0, e to the 0 is 1. So the left-hand limit and the right-hand limit are the same thing. So we know from this that the limit as x approaches 0 of f of x is 1. So now we just need to say that f of 0 is equal to, well, which of these pieces do I plug 0 into? This has the or equal to. So f of 0 is 1 minus 2 sine of 0, which we found earlier was 1. So now we've shown the left part to be true. We've shown the right part to be true. So our justification is going to be the limit as x approaches 0 of f of x equals f of 0. And we have to say what that equals. We can't just say this because they told us in the problem it is continuous. We have to tell them not only that, but both of those things are equal to 1. So we need to convince ourselves that the limit exists. So that was 2. Condition 2. We need to convince ourselves that the function exists. That's 1. But all AP is going to be looking for is your justification here. So this is what you're going to see free response-wise. Continuous on multiple choice is going to look something like this. Find a value a so that the function f of x equals x squared plus x plus a is less than 1, or if x is less than 1. And x cubed, if x is greater than or equal to 1, is continuous at x equals 1. So they're saying there's some value of a that's going to make this thing continuous. So if we think about our definition, we know that the limit from the left and the limit from the right have to be the same thing. Not only that, but it has to equal what f of, in this case, 1 is. So if we think about the limit as x approaches 1 from the left of f of x, that's got to equal the limit as x approaches 1 from the right of f of x, and that's got to equal f of 1. So we just got to figure out what f of 1 is, and then make sure that the limits are the same. So we really just need to find f of 1 up here, f of 1 down here, set them equal to each other, and solve. So if we think about that as far as the limit goes, the limit as x approaches 1 from the left of f of x is going to be equal to 1 squared plus 1 plus a, which is 2 plus a. The limit from the right of 1 is 1 to the third, which is 1. So we know if the limit's going to exist, 2 plus a has to equal 1, or a has to equal negative 1. And to make sure that we're continuous, right, this value of a makes the limit exist. If we plug negative 1 in for a, like I said, the limit's going to exist. If we plug 1 in, we would plug 1 into our function here. F of 1 equals 1 to the third, which is 1. Our limits are going to equal 1, right? This limit equals 1 if a is negative 1, 2 minus 1 is 1, so a equals 1. Now, in the 2 minutes that you have to answer these questions, all we really have to do, we don't need to think about the limits. This is just showing why we're going to do what we're going to do. But what we really just want to focus on is that x squared plus x plus a has to equal x to the third when x equals 1. if we think about it this way, we're going to get to the same answer. We're going to get to it quicker, and that's going to save us some time. So when x equals 1, these things have to be the same thing. So that's 1 plus a equals 1. So a is going to equal negative 1. So when you see these multiple choice, I don't want you to go through all the stuff with the limits. Just set the two sides equal to each other, plug in the x value in question, and then get your answer for a. So that's going to do it for this video, and then we'll see you in the next one.